Hello guys, how are you all? I hope you are doing well. I am back with my YouTube channel presenting a new video session. Before that, please don't forget to like, share and subscribe to my YouTube channel. This video is based on research article number 2, that is IoT enabled smart agriculture system, that is simulation setup and parameters. Yesterday we have discussed about simulation model and software hardware tools. I told you that we need different kinds of sensors, display module, SPI device and gateway for simulation of IoT enabled smart agriculture system. Today we will discuss about simulation setup and its parameters, such as we will discuss about temperature data, pressure data and soil moisture data with the help of suitable diagrams. Let me start with the introduction of how to set up simulation for IoT enabled smart agriculture system. Here, for simulation, we need several environmental parameters such as temperature, pressure, humidity to be taken into consideration as we have discussed yesterday. We need to simulate the temperature between the range of 20 degrees Celsius to 40 degrees Celsius. Got it? From 20 degrees Celsius to 40 degrees Celsius. Then we need to set the values of pressure in the range of 1010 hectopascal to 1025 hectopascal as I have written. For soil moisture, we need to simulate it between 10% and 50%. You need to be very careful about these values. Okay. Rainfall detection is represented either in the form of presence of rain, that means rainfall is present, or no rain means no rainfall is present. So rainfall detection means it will be optional in the form of random, yes or no. The Raspberry Pi receives inputs with the help of these parameters and processes the data, and further the data is sent to the ThingSpeak platform or to the cloud. So this figure represents the simulated temperature data. The figure represents time on x-axis and temperature sensor on y-axis. That means on y-axis we can get the values of temperature, the fluctuating values of temperature. We can see the fluctuations in the temperature sensor data only for the duration of 1 hour. Means for 1 hour we have set our simulation that for the duration of 1 hour we can get the values of temperature, the fluctuations in the temperature for the time duration of 1 hour only. I hope you understood it. Now we will discuss the fluctuations in the temperature data over 1 hour duration. So I have shown you the figure. We will discuss about that. In the beginning, specifically between first 3 minutes, you can see from the figure, the temperature rises abruptly during the first 3 minutes and it rises till 37.72 degrees Celsius. So the value is very high. This high temperature indicates low moisture, means when the temperature is high, the moisture is very less. And the crop stress rises. After that, between 4 to 5 minutes, the temperature decreases to around 22 degrees Celsius. And it will generate the possibility of rain or cooling condition. That means at low temperature, the possibility of rain or cooling condition is there. At high temperature, that means low pressure is there and the crop stress arises. So with less temperature, the conditions are generally favorable for the growth of plants. Means there will be the possibility of rainfall. Got it? Now come to the pictorial representation of pressure data simulation. We can see from the figure that time is represented on x-axis and pressure on y-axis. We can see the pressure, values of pressure on y-axis and the values of temperature on x-axis. The fluctuations in the environment variable, that is pressure, can be seen in the graph, but here we can get the fluctuations for only 1 hour time duration. The same we have done in case of temperature data simulation. For the same time duration, we have seen fluctuations in temperature data. So the graph illustrates how the pressure changes over a specified 1 hour time duration. Clear? Now come to the pressure data. I hope you understood the graphical representation of pressure data simulation. We will discuss about the graph here. The graph shows pressure variations over the time duration of 1 hour. The range of the pressure data is set between 1010 hectopascal to 1024.81 hectopascal. I told you previously also in the first. There will be the phases of high pressure and low pressure systems as shown in figure. There will be low phases of pressure as well as high phases of pressure. That's why we call them fluctuations in the pressure data. For instance, if we can see the increase in pressure around third minute, as we can see from the graph that around third minute the pressure is increased. What does it suggest? Do you know? It basically shows high pressure, which could simulate clear skies and stable weather conditions. That means if high pressure values are there, the sky is clear and the weather is stable. The drop in the pressure we can also be seen around fourth minute from the graph, which shows cloudy weather. High pressure shows stable weather and low pressure shows cloudy weather or rainfall type environment. Thus, there is an urgent need for monitoring environmental variables to mitigate, to reduce the adverse impacts of weather anomalies. I hope you got it. Come to the next soil moisture data simulation. The next turn is of soil moisture data simulation. Here again in the same way we have taken sensor data, means soil moisture sensor data on y-axis and time on x-axis. The fluctuations can be seen from the diagram. You can see how soil moisture level abruptly changes over a period of time. So I hope you got it. Coming to the explanation of the previous soil moisture data, we have soil moisture simulation value ranges between 12.67% to a maximum of only 48.34%. What does these value represents? You have to consider these values for simulation. These values represents the moisture changes. That means it can go up to high level or it can go up to lower level. Minimum value is 12.67% to a maximum of 48.34%. Let us take an example. We can see an increase in the moisture level around 8th minute. You can see from the figure that around 8th minute this signifies a period of irrigation. Around 8th minute the moisture level increases. That means this is a period of irrigation or rainfall. Whenever there is higher moisture in the atmosphere, there will be chances of rainfall. So this period is crucial for improving soil conditions for the growth of plants, because in this phase only the plants will get water, natural water. Rainwater is the purest form of water and it will improve the soil conditions for the growth of plants. So this period helps in improving the efficiency of the system too. Also we can see from the figure that around 6th minute, you can see from the figure that around 6th minute the period represents increased evaporation or lack of rainfall. Around 6th minute, the period represents evaporation increase. That means temperature is increased and the humidity, level of humidity is also decreased. That means there will be chances of no rainfall. So these insights can be used for effective crop management, which helps in saving water and energy consumption. That's all for today. I'll be back with some more interesting research articles. Till then, stay tuned to my channel and please don't forget to like, share, and subscribe to your friends. All the best. Have a nice day. Thank you.